I was actually in one of these B through D courses, got the highest grade, and it was a B. Good. He was waiting for like some kind of deity to come along, and then they would have gotten an A minus or something. Anyway, I'm still a little bitter. I'll be right. Do you understand? So what is the extra information? If I just told you they both average a C, that doesn't help you distinguish to tell what to take. I also needed to know an idea of the spread of grades. How spread out are the grades that they get? Maybe. So which one of these sets of data is more spread out? In fact, we got to talk about what spread really means.
The second one.
Yes, I love it. So here's what spread is going to mean. Spread is going to mean the average distance to the data points from the mean. So on average, how far do the data points get away from the center? And if you think about it,
2.
no, so we're going to have to calculate it. You can't really, it's a little more to it. Yeah. But I like what you're trying to do. Right? So in that first set of data, this first set of data, the 3 middle points don't even get away from 5, but the 2 other points do. Right? I like it. And then this one, more of them get away from home, right? The parents are like, thank God they got out. Okay, maybe. So whatever number we calculate that measures the spread, it's got to be bigger for this one than it would be for that one, or else it's shit. I want to figure out, I know a number that measures where the middle is. Now I want a number that measures how spread out the data is. That's equivalent to the B through D or A through F. One was more spread out than the other. Are you guys with me? Okay. All right, so let's figure out how we're going to do this. So let me write up here this, because I don't know, I didn't see a lot of people writing. When I slow down in what I'm saying, that is a note to take. Holy shit. So this spread, I'm going to give it its official name. It's called the standard deviation. We want it to be the average distance from the mean to the data points. I like that. So just like some cities, has anybody ever been to Denver? Do you know how spread out Denver? You know what I mean? It's like the city itself is like spread way the shit out. I kind of hated it. And then I was in, was it Kansas City or somewhere? Maybe it wasn't Kansas, St. Louis? Yeah. And it's just so like, wow. So that's an idea of like how spread out a town is. So the standard deviation of St. Louis to all the buildings from the center of the city would be smaller than frickin' Denver, right? Denver just was like, let's use all this land. I don't blame you, but still. Okay, so what we're gonna do, let's do this first set of data. Let's write it down this way. Okay, so let me ask you this. If I wanted to find, just bear with me. If I wanted to find the average age in this room, I would first have to get a list of
our ages.
Ages, 11. If I wanted to find the average shoe size, I'd first have to get a list of shoe sizes. What average do I want to find? The average distance from the mean. So I need to get a list of distances from the mean, right? Average blank. I better get a list of blanks, or else how the hell am I going to average them? Do you guys understand what I'm saying? And what we're about to do, we are getting into the construction of the formula. You're never going to have to redo it. You're just going to use the formula. But the more you stay with me, the more sense the formula will make. So, what the shit? How do I do the distance from the mean to the data points? How do I do that? And let me tell you one thing. Let's call these populations, because there will be a little bit of a difference for samples. So let's call it a very small population. So obviously, to find the distance between two numbers, what operation do I fundamentally have to take? The difference, right? So then x minus mu. Isn't that how far a data point is from the mean? I like it. So what do I get for each thing? What's the mean again? 5. So 1 minus 5?
It's 4. Negative 4.
There it is. 5 minus 5, 5 minus 5, 5 minus 5, 9 minus 5, 4. How you guys doing?
Okay.
Now, nobody yelled at me about this, but you're going to see this. What does this add up to be?
0.
In fact,
negative 0.
if I do this for any set of data, it will always add up to be 0 because that's what the mean does. It has equal amounts negative as opposed to positive. So some of you guys should be like, thanks, Jeff. Good job, buddy. You led us down this road. You always get 0. What the shit is that supposed to tell me? So what we got to do is we got to correct this. Now, nobody yelled at me about this, but what is the actual way to measure distance in math? What operation? I know subtraction is a part of it, but what is distance? Distance. Anybody know?
Inverse.
No? There is a function who's always got to come out positive. Absolute value. Absolute value is the distance from 0. That's why the absolute value of negative 4 and the absolute value of 4, they're both 4 because they're both 4 away from the middle. Now we're not going to use that. And I'm going to tell you why very quickly. There's a lot more to the story. Does anybody know what an absolute value looks like if you graph it?
No. Isn't like the negative and the positive?
It's not a u, that's x squared.
It's a V.
It's a v. Because what's the power on absolute value of x? First power. So it's a line.
Can you show?
Yes. That's the whole thing. Yes. So an absolute value, let me do it. Absolute value is going to look like this. What's the absolute value of 1?
1.
What's the absolute value of negative 1?
1.
What's the absolute value of 0?
Ooh, I never seen that.
So it looks like a v.
Maybe on like a little.
What's the matter? What? That's it. That's what it looks like. Absolute value 2 is 2. Absolute value 3 is 3. Isn't that a straight line? What's the only way you can have a curve is if there's a power that's not 1. Like x squared, right? So is that a plane you want to be in? Let me show you. Thanks for flying with me on Airbus Airways. We'll just be taking a little bit of and you're dead. You're dead. You're dead. That's insane. So there's a whole mathematical thing behind that silly thing I just said. We really don't like where, and to be honest, to get really a little more technical, the slope changed instantaneously. You with me? Does that make sense? That's negative slope, and then bam, that's positive slope. Everybody dead, right? So you already kind of told me this. What's a gentler way to go around there is not to use absolute value, but to use x squared. That makes things positive, and here, thank you for flying. We're going to make a turn. Okay, everybody's fine. Right? You're not dead. That's still kind of a tight term, but you're not dead. Whoa, okay. Instead of dead. Okay. So what we're going to do right here. Everybody understand what the problem is. I'm not changing the fundamental thing I'm trying to get. It's just I'm saying, shit, this always adds to 0. Stupid negatives. That one sucks for all kinds of weird reasons. Let me use the nice one. So I'm going to square these. Why am I squaring them? To kill the negatives in a more gentle way. So what does that mean I got to do at the end?
Square root.
Square root. Because I don't want the average square distance, I want the average distance. So the last thing we're going to do is take a square root. So what do we get here? 16? 0. 0. 0. 16.
36.
What? What? I don't know what's happening here.
I know we're wrong.
You guys are... So how do you find the average? I'm going to find the average of these, and then I'm going to take a square root. Because remember, what's the whole idea behind what we're trying to do? Average distance from the mean to the data points. So if I find the average square distance, I can take the square root.
So every time like you put like a square or the third line, we're only doing it in the middle.
No. What? No. You're right.
But
don't say
doing it
every
at the
time.
end.
What am I squaring? I'm squaring those, right?
Mm.
And where are those? Here. you see what I'm saying? So it really depends on what you write here to look at, to square the right thing. Yeah.
But
So don't just say it's always the one before it.
If it's not a number in the parentheses, you have to put a square to do that, right? So say, like, you know how you just said that's x negative m or u?
Yes.
You put that square because there's no number right there, right?
No, I put the square to kill the negatives. That's it.
Okay,
That's
only
all.
if it's negative, right?
All right. So what we're trying to do won't work if
It's
these
serious.
always add to 0.
Okay.
Right? So we could have taken absolute value to kill the negatives, but we said there's some problems with that. So we squared instead. The only reason I'm squaring here is because if I want an average, and these are always 0, that's not going to get me anywhere. Let me square them, kill the negatives, and then I'll square root at the end. Don't try to generalize what we're doing here. It works for this situation. It might work for other situations, but we'll have to get there. It works right now because it makes it not negative anymore. Okay. So how do I find the average of these? So now I got a bunch of numbers here, right? How do I find their average? Add them up. What's the symbol for that?
Sigma.
Add these up and then divide by how many there are. Here's the symbol for this. This should hopefully not be a big surprise. The symbol has a square on it because I haven't taken a square root yet. That symbol right there is lowercase sigma. It means standard deviation. But when it's squared, it's called the variance. So before you take a square root, it's called the variance. I know it can get really easy to get lost with everything. Just keep in mind, this is what we're trying to do. Every step we've done is going in this direction. And again, you're never going to have to do all the same thinking. You're going to have to create tables like this, but we're going to have a formula to work towards. So let's see, what do we get for the variance? What is this? Yeah. 32, isn't it? Sum these up, you get 32.
Yeah.
All right, so the sum of these bad boys, 32. So wherever we see this thing, I can put a 32. And what's n? 5. So what do you get for the variance? 6.4. I love it. So then what do you get for the standard deviation? You take a square root, right? Because if these represent dogs, this is square dogs. What the hell does that mean? I want to go to your house. Fluffy got into the trash compactor. Somebody, like in my last class, they're like, oh, it's the imaginary dog. It's all right. So I got to take a square root so I can get back to normal stuff. What is the square root of 6.4? Give me a few places to work with. 2.5. Oh, I love you guys. 2.5. 298. Okay. And then more shit, right? Always round standard deviation to at least 3 decimal places. At least 3 decimal places. Yes? This one?
Oh, you have to
What does
go-
n always mean? The number of data points. Yes, I like it. So what does that mean? What does that 2.53 thing mean?
The distance.
The average distance from the middle to all the data points. I like it. So if I did it for this set of data, would this number come out bigger or smaller for this set of data? Bigger, because they get away from the middle more. So its standard deviation should be bigger. All right, so let me give you this. I've got on this sheet of paper, one side is a completely worked out problem with kinds of answers that I love to give you on quizzes and tests. And the other side, same stuff, just blank, so for you to do. Before I do this, I have 2 things I want to show you. Well, one thing I got to do, and then I'll give you this. I always almost forget this. What was this whole thing about? It was about a population, right?
Yeah.
Okay, now watch. Stay with me. I'm going to explain why this is, and then I'll give you a shortcut way to remember this. All right, so there's an average age in this room right now, correct? There's this. and everybody is so far away from that average mean, and I could figure out the standard deviation. If I took one row at random, right? You guys, that was so random. This gets a little weird. Stay with me now. And I take their average. Would their ages be closer to their average or to the average of everybody?
The average of everybody.
Their ages would of course be closer to their average. What if they happen to all be really young? Right? You with me? Then their average age would be lower and their actual ages are lower. They would be closer. You guys get the idea? So any sample I take, if I use the same exact formula, it's going to be smaller than it's supposed to be. Because of course they're going to be closer to their own average. So what we're about to do is a little tiny adjustment for a sample. That's the quick way to remember this. So the formula I've got up here, let me write it over here. The formula I've got up here is the formula for population. How can I tell? It's a freaking Greek letter. And this is the lowercase sigma, which is lowercase s in Greek. So of course for a sample, I'm just going to use the actual letter s. So if I have a sample, one thing that changes is it's going to be x bar here. Is that cool? It still freaking means mean. It's just the mean of a sample now. And here's the adjustment I make. If I need to make a division come out bigger, right? Because what's the problem? Any sample I take, their spread would seem to be smaller than it's supposed to be because they're closer to their own average. If I want to make the division come out bigger, to adjust for that, I have to divide by less. Right? If you divide by less, doesn't your answer come out bigger? So the exact thing I actually divide by, yes. And real quick, we've seen this guy already. You just didn't realize it. Remember that thing we did where I said I have three numbers that average to be 10? Did I do that with you guys? Does that sound familiar? No, I didn't ever. If I have three numbers that average to be 10, how many of them can I just totally make up before I have to get serious? If three numbers average to be 10, what do they add to be? 30. So as long as they add to be 30, I'm golden. So can't I just how many can I just totally make up before I have to really make it work? Somebody give me a number. 15. Somebody give me another number. 12. Now, can this one be whatever it wants to be and have it average to be 10? No. What do I got so far? 27.
16.
So this guy's got to be what? 3. So it adds to be 30. What's the only way three numbers can average to be 10 is if they add to be 30. So how many numbers was I free to just do whatever the shit I wanted with them? 2 of them, which is 1 less than how many there were. So this little dude is called the degrees of freedom.
Yeah, I don't get that one.
Do you understand that if you have 3 numbers and they average to be 10, they have to add to be 30? How do you find the average? You add them all up and divide by 3 in this case. What do you divide by 3 to get 10? 30. The only way that 3 numbers can average to be 10 is if they add to be 30. Because 30 divided by 3 is 10.
So you just want to find something that equals 10?
So how many numbers of the 3 can I just totally make up without even thinking? And then when do I need to start getting serious to make it come out to add to be 30? I can make the first 2 whatever the shit I want to.
But just make sure that last one equals.
Yes, so how much freedom do I have? 1 less than how many there are. Because it's the last dude that I got to get serious. Okay, cool. All right. Let me give you this. What's that? Yeah. Let me give you this, and then I want to show you something on the calculator. There's one for Of course, I'm all running around. So one side of this is a completely worked out problem. I want to look at that side first. See if I really want.
Damn it.
I have one more. I need two more. Huh? Sorry?
Oh, we're doing the back by ourselves, right?
Yes, but hold on. Let me show you something. Look on this side first. Sorry, two people back there. You're gonna have to hold on. I always forget how many freaking people I shove in this classroom. I want to show you how to do this. Oh yeah, somebody's got my calculator, right? I got this one. Can I have my calculator for a minute? Who's got my calculator? So watch this. It's kind of cool. So that's the same table we just made, right? Mm-hmm. Okay. So let's all go into your data. So we did a little bit of this before. Hit Stat, Edit. Right? Stat, Edit. Kick ass. Okay. So everybody should be here. Let's clear out this first list. Go up to L1 and hit Clear. Enter. Make sure your second list is clear and your third list is clear. Everybody all right? So let's put this data in here, 12589. If you'll notice, it's the same set of data up on the board, right? That second set of data. All right. So now look what I did for you. I put on L2, I tell you how to put this in the calculator to make it do it automatically. Now this is not a very large set of data. You can do each row one by one. But I want to show you how to make the calculator do it all at once. So what do I want L2 to be? I need it to be all the x's minus the mean. All the x's are in L1. So I want it to be L1 minus the mean, which in this case was 5. We already calculated the 5, right? So what do I need list 2 to be? I need list 2 to be x minus the mean. Where are all the x's? L1. So I want list 2 to be L1. Hit second 1 for L1. L1 minus the mean, which in this case was 5. And then you just get all those numbers like I do here. Right? So if you've ever used Excel, it's a little bit like Excel, just worse.
Mine says error data type 1.
So make sure you can't put an entire list of data into one spot. Make sure you highlight, let me do it again. Make sure you highlight L2. So you're not trying to shove a whole list into one spot. Calculator's going to kind of push back at you.
Go back.
Go back to where?
Like erase that number L2. It's like 5.
Push the up. No, just do.
What's that?
No, just
What's that?
highlight it.
What happened? You're good. Go up to L2.
Push second. And then push L1.
Yes, so now you tell it, when you got L2 highlighted, you tell it L1, second 1 for L1. There's your L1.
Yeah,
Minus 5. So it says L1 minus 5. Bam! So in your head, when I say L1 on the computer, on the calculator, you know that is X. So it is exactly what the formula would be. And then of course I want the last column to be all the stuff in L2 squared. So I just go up to L3 and say it's L2 squared. Bam. And then you can just add those up. So you guys try to start doing the one on this side. It's not a bad idea to sort them, but you don't have to sort them. What's up? No, sometimes. All right. Show me what you did. You want to make it square and Square. Yeah. And there you can see that. Don't you get these? Cool. I want you to do the other side. Let's get as far as we can. The last class, I didn't quite get done with it. I told them I would bring the answer key of this the next time. Oh, while you guys are doing that, I'm going to pass out the practice test. And on Tuesday, I'll have an answer key for it.